Example 2, what if you had a parabola? Okay, so again, they've been really nice to you because they've already drawn the graph. It could have been that the question started without any graphs and they just said, can you please graph the square root of, and this is x minus 3, move 3 to the right, down 4, x minus 3 squared minus 4. So then you would have to graph the parabola shifted 3 to the right and 4 down first. Then after you've graphed that, you would look, are there any places where the y value is 0? Yes, here and here. Any places where the y value is 1? Yes, again, there and there. Between 0 and 1, can you graph it slightly above? Okay? And here's the one place where I see so many times students lose a half mark because they want to, like that went back in time. Right? I can't go over that line that I started with, so I need to. It's really hard to show that it's above. Sometimes the best you can do when you're connecting them to oh, that one, I'm happy that's on video. That looks really good to be slightly above. But sometimes the best you can do is show it like just exactly on there. Do we have any nice points? I guess technically here's where my y is 4 and 4. So when I square root that, that will be 2 and 2. If I would take this graph, if it was on Desmos, and I could say, hey, let's zoom out 1,000 times. You know how the shape of a square root graph is normally like that? This one eventually is going to get like a straight line. And maybe it makes sense to you because if this graph is a parabola, which is an x squared, and you square root an x squared, you would just get an x. So this graph eventually doesn't bend as much as a normal square root because it would end up in the shape of an x graph. Same thing, the second one. If they wanted to make it more difficult, they would just start like this. Can you graph negative x squared plus 9? You recognize that that's a parabola flipped upside down and then shifted up 9 units. Oh, we didn't do domain and range. Domain and range is a little bit tricky on this one because you have two different chunks of your domain. So you could either write it this way, x is less than or equal to 1, and then write the word or, x is bigger than or equal to 5. That's how you would write it in set notation. You'd have to include the word or, not the word and. And in integral notation, this would be negative infinity to 1 with a square bracket, or is a big U, square bracket, 5 to infinity. So just showing you that different notation. The range is still y is bigger than or equal to 0. Fine. Second one. We've graphed the inside. The parabola's already been graphed for us. Yes.
Why do you write or not and?
In mathematics, and says you have to be in both places at the same time. And you can't be both less than 1 and bigger than 5 at the same time. Or says it's true if it works in this section or in this section. So it's like some logic problems with and or. Second graph. Do we have a 0? We do. Do we have a 1? We do. Between 0 and 1. This is almost impossible here. Slightly above. Oh, but I did it. I did it. Oh, that one's not. And then any nice points on the inside? Well, here's 9, here's 4, and here's 4. So if I square root, that'll be 2. This will be 3. This will be 2. Connect the dots. So much fun. So square rooting a parabola can look extremely different. Right? Both of those are square roots of parabolas. The one on the left, the graph looks extremely different than the one on the right. The domain, when you're in between values, you could either write it like this, or like that. Same thing with your range. It's in between values. I quite like the interval notation when it's in between values. Questions for practice on this one? Just number 8.